Yeah.
So is everyone able to see my screen now?
Yes.
Okay. Hello all, my name is Avinash. Welcome to the MuleSoft Meetup in Charlotte, and we are doing it online. So I'll be speaking on DataWeave 2.0, and I'll try to cover most of the basic topics. It would be helpful for the people who are trying to learn more about MuleSoft and trying to move to MuleSoft. I'll be starting with basics, and I'll be doing a demo, and I'll be also doing a demo on how we can install Docker and use the DataWeave instead of just using the IDE and using the DataWeave component to test your script. So let's get started here. So what is DataWeave? We all know MuleSoft is an integration platform as a service, which is used to connect different applications and transformations. So
hey,
DataWeave is yeah.
Hey, sorry, but I think on chat, Subhash, some people are saying they are not able to see the screen, and I think somebody is requesting to turn off the video. It does make sense for those who don't have enough bandwidth, right? So
okay.
I'm gonna turn off my video too.
I'll do that too. So I hope everyone is able to see my screen now. I'm not looking at the chat. Subhash, please let me know if anyone has, if someone is having problem. We all good now?
Yeah, I mean the person who was not able to see, he's saying he can see it now. So I would say.
Okay, perfect. Yeah, so going back, so DataWeave is a programming language which is designed for transforming data, and it's one of the core components of MuleSoft. Like, we mainly use it for transforming the data, and it is MuleSoft's primary language. In Mule 3, we had Mel expression, but when we moved to Mule 4, we have only DataWeave 2.0 as a primary language. It is also the expression language which we use for configuring our components and connectors. So basically, a DataWeave file consists of two parts, which is header and the body. In the header, we define the directives, and in the body, we usually describe the output structure, the output which we are trying to achieve, right? So I have a basic example here. So you can see that the upper section where you have the DataWeave version and the output is the header, and you have the delimiter which separates the head and the body of the DataWeave file. And you can see the lower part of the file has a script which will print our output. So that's the basic structure of the DataWeave file here. And then we have a data sense in DataWeave which supports the metadata from connectors, schemas, sample documents, and it makes our lives easier to do the transformations. And it also provides the content assist, like when you're coding, and it auto generates the lines of code from actions performed on UI. Like usually you can just drag and drop the components and do the mappings, and it will automatically generate the code in the output section of the DataWeave. So if you look at the picture down,
Hey, Avinash, you went on mute.
Yes, I think Avinash went on mute.
yeah, can you hear me now?
Yes.
Yeah.
So how long has it been? Was it just this slide?
Just the last slide, yeah.
And okay, I don't know what happened. It's automatically put me on mute, I guess.
Yeah. And I guess when you are sharing screen, we are seeing the left, your main slide, and also the slide preview. So it's not full screen.
Yeah, full screen. Make it full screen.
Yeah.
Full presentation mode. The bottom right.
I believe if you have another monitor, I think the full screen is
that's
going
what's
to the...
happening actually. I have two monitors, and the one in the main monitor is looking fine for me, but the one on the left is kind of like, it has next slide and the preview and everything.
Maybe when you share screen, when you reshare screen, I think it will ask you to select which monitor, and maybe that's when
there's a duplicate. Yep, this is good. Yeah, I got it, I guess. Is this better, guys?
Yes.
Yeah, I think it's full screen now.
Okay. Yeah.
Still, there were a few people who were not able to see.
Okay, sure. I can go like a couple of slides back, and I'll just repeat it, I guess. So it's good now, right?
Yeah, it looks better now.
Okay, sure. So yeah, as I was explaining, so DataWeave files are basically categorized into two parts, where we have the header and the body. Like you can see in the screenshot below, where we have the DataWeave version and the output type, and then there's a delimiter which is separating the header and the body part. And you can see the lower part is the body, and this is where we can create our using the script we can create our output. And also we have data sense in DataWeave, which creates a metadata from the connectors, schemas, and sample documents, which makes our lives easier and helps us do the transformations and mapping very easily by just clicking on the UI itself. So if you look at the picture down below, we have an input section, output section, preview section, and the DataWeave section. So you can see that the middle part between input and output. So once you have that input and output metadata populated, you can just drag and drop the fields, and it will create the script automatically in DataWeave for us. I'll try to show that in the demo after this. I'm done with the slides. So moving forward, it continues. Like you can see here, technically, we have the input, like an XML payload on your left side section of the transform message, and on the output, we have a JSON. And you can see that we have just dragged the title field to the title field here, and it automatically creates the script in the DataWeave file for us. So it's pretty easy when you have the input and the output metadata populated, and you can do the transformations and mappings pretty easily. So when you're migrating from DataWeave version 1.1 to 2, so these are the major changes. And let's say if in your company you're doing any migrations, and I hope this will give you an overview and help you do the migration pretty easily. So apart from syntax changes, so there are many other new features in DataWeave 2.0. So there are language simplifications, and everything is now a function. We used to have the operators in Mule 3, but everything will be a function going forward in DataWeave 2.0. And DataWeave scripts can be now packaged and reused by the new imports in the module features. And then we also support the multi-line comments in DataWeave 2.0. And we also have the support for calling static Java functions directly from DataWeave itself. And coming to the DataWeave header content, you can see on the left side of this table, I have the DataWeave 1.0 from Mule 3, and on the right-hand side of the DataWeave 2.0. So you can see that the syntax has changed, and we have the 1.0 and 2.0, and we don't have the percentile anymore for the output type variables, functions, and namespaces. So that's the header content which has changed from DataWeave 1 to 2. And then one other major change was we used to use when otherwise in Mule 3, and I'm sorry, in Mule 3, and in Mule 4 we are using if else. So this is we have a sample example here where, like, order status is complete when you're trying to check the condition, and then you're using otherwise. And when it comes to Mule 4, you're using the if, then condition, and then else. And coming to the pattern matcher, it also has changed a lot. You can see that for pattern matching now you can use case and else keyword instead of default. So that's the new way of doing pattern matcher in DataWeave 2.0. And we have removed, I think we have seen that from DataWeave 1.22, we have removed the type references, like the colon was removed. And you can see the example where payload as object in Mule4, we have it like &a, which replaces that colon there. And type names, as I said, we have changed the references, and in DataWeave 1.0, we used to refer, if you're trying to refer it as a string, you used to do colon string, but now we have like a name with starting with uppercase, and you can see that in the example payload.foo as string. And as I said before, everything is a function, and we used to have operators in, sorry. So we used to have operators in Mule3, and everything is a function, and Mule4, and we can see the syntax example here. And XML format. So the default reader property null value on is empty for DataWeave 2.0. But if you were working with 3.x, you should have seen for DataWeave 1.0, the value is none, and you can see it in the example here. For Mule3 DataWeave 1.0, when the null value on is none, you can see the output, you're only getting the fields which are null value on is none. And concatenating two strings into a single string. So in DataWeave 2.0, it's kind of similar to the one which we had in DataWeave DataWeave 1.0, like beginning with a simple DataWeave script. This is just a basic script, like when you're trying to concatenate two strings. So which is like you'll be just using a ++ operator to concatenate both the strings in DataWeave. And transforming the JSON input to XML output. So DataWeave makes it pretty easy for us to transform the data. So simply changing the output type to the way you want, you can see the output. So for example, let's say you're having a JSON input payload coming in, and you want to transform it to a XML or Java. You can do it pretty easily by changing the output type. So you can see that it's mentioned that this processor uses the input directive to produce XML output from the JSON output. So that's the simple example which I have in the screenshot below here. And defining and using a DataWeave variable as input. So you can define variables in the DataWeave itself, and you can use it in the output section. So for example, if you see this syntax below there, we have a variable myJSON declared in the header part, and it's being used in the body part, and you can see that the output hello world is printed by accessing the variable in the body part of the DataWeave here. So and also you use a DataWeave function in DataWeave variable. So we can see that if you look at the screenshot, you can see that the variable myJSON is declared there, and you're using a function inside that variable, and again you're calling the variable in the body, and now you're able to see the output, which also used the where we have seen that the function was used inside the variable. So you can see that the average is printed, and you can see the output here in the previous section of the DataWeave. And mapping elements from an array into an object. So we use the map function when you are trying to map different elements of an array into an object. You can see that we had an input array of ABC, and we are trying to map it to the values. So we can see that there's a output object where we have an index and also the values populated accordingly there. So we have many other elements which you can explore. We have a map object, and there's a pluck operator, and there are it's called a function right now in Mule4. So everything is a function now. So you can explore a lot in the documentation. I can give you a link at the end of this presentation. And so there are multiple functions, and I have try to put some core functions here, like core, arrays, binaries, encryption, objects, runtime, string, system, and URL. By default, we have the core modules automatically imported into the DataWeave. But if you want to use any other modules, you can import it into the header part of the DataWeave using the following syntax, which I have here. So for example, if you want to import the libraries for strings, you can do like import DataWeave core strings. And similarly, you can also import different other modules into the DataWeave using this syntax. And then these are some of the functions which we use to work with arrays. There might be some other functions which we use during our everyday work, like join, split it, sum by, and count by. So these are the basic functions which you use regularly every day with your arrays. And this is also provided in the documentation, and exploring this would help you get an idea, like, what are the different functions we're using with arrays. And I'll give you a little demo, and I'll walk you through creating a sample application, and then using the DataWeave component. Let me stop this and share my studio. So I'm just going to go ahead and create a sample application here. Name it test app. Yeah, please bear with me. My system has only 8 gigs of RAM. The recommended is 16, especially with Mule4. Okay, there we go. So I'm going to just drag a flow into it, and then transform message here, which is a DataWeave component. So you can see, as I was explaining the slides, we have the input, output, and we also have the file section, and also the preview where you can see the output once you have the input, output, right? So I'll show you the way we can define the metadata manually, and we can also get the metadata automatically by having the connectors before and after the DataWeave component, which is transform message component. So in our case, if I want to just load a sample JSON and give it as an input, I can just go ahead, define, and then sample JSON, and create a type here, and then you can select the type as JSON, and then you can select your example, and then load an example file which you have, just like sample JSON, some random JSON, and then you can see that the metadata is populated on your, just give it a second, it's trying to load the metadata. So you can see that the metadata is loaded here, and also in the DataWeave, let's say you want to see the output, and right now I'm outputting the data type as Java, and you can see that it's printing the Java output. And if you want to say, let's say you want to transform it to XML, you can transform it to XML. And if you want to extract a particular element or a certain section of data, you can do like payload.quiz.sport. So you can see that I have extracted required data from the input payload, and you can also transform it to, like, if you just wanted to transform it to JSON and just look at the certain data you want to look at, so you can see that it's getting transformed to JSON. Let's say, and I also wanted to show you the mapping part, where I said, like, you can easily drag and drop and do the mapping. So I'll try to load a address JSON in my input. So what I'm going to do is find metadata. I'll try to input a new file which will contain the address JSON addresses. And I'm going to create a file, and then I'm going to repeat the same steps which I did before. So I'm going to select the example. It's going to be a different example file. It will contain a sample address. Looks like I have an issue with this JSON here. Well, let me go ahead and look at the example I had. Yeah, it looks like it's small form. So let me define the output, and I'll show you the way we can map it using the UI. Wow. Okay, some things are miss here. I'm not able to load my sample files here. Okay, I'll do one thing. I'll try to work on this, and if you have any time at the end of the other presentation after Tom, I'll try to find a solution for this. So I also wanted to show a demo on how to use the DataWeave in your browser. So it will help you, like, if you want to test your DataWeave scripts, and if you feel like, oh, it's a big task to open your studio, create application, put in the DataWeave component, test it. Instead of doing that, you can install Docker, pull an image, and directly test your DataWeave script. So I'll guide you through this process, and I'll install it step by step. So I'll share you the link after this presentation. So we have an article out there which will help to run our DataWeave Playground Docker image locally on your own system. And there is also a way you can access it in browser. So there is a IP address which I will also link it at the end of the presentation, where you can access it. So let's say if you're trying to install the Docker, so there's the step-by-step instructions. You go in there, go and install the Docker desktop. I have downloaded the zip file already. So I'm going to the downloads and install the Docker here. Just bear with me for a couple of minutes. My system is kind of acting up and it's kind of slow. It shouldn't take more than a couple of minutes, and it would take like a couple more minutes to configure, like, pulling the image and get it up and running and test some of your scripts. So meanwhile, we'll go through the next steps. So once you have the Docker installed, so the next step would be going and pulling the image, which we are going to use in the Docker. So once the Docker is installed, in your tray little section here, you should be seeing, you should see that it's up and running. And now you can see, I think I can see it in my tray right now. So it means that it's still getting installed. So once it is installed, you can see a status saying that Docker is up and running. And once it is up and running, the next step would be you need to get the image, which would help us load this DataWeave playground. So you also have a link for the image here. So the next step would be you will be just copying this image here, and then try to pull the image to your local local machine. So let's see if the Docker is installed successfully. It's okay. It's still getting installed. Yeah, there you go. So the Docker is installed successfully, and now if you can't see the status in your taskbar, all right. So you can see this little icon where it says the Docker is starting. So you should wait for like a couple more seconds when it says it's up and running. So the Docker is up and running. The next step would be we need to pull the image here. So let's go. I think I already copied the link here to go ahead and pull it, right? So I want to go to my folder here. Then I'm going to pull the image. So you could see the status that it will download, and once the download is complete, we should see something similar like this. And once it is pulled, we can go ahead and start our playground. So this is the easier way to test your DataWeave scripts. Even if you find it hard to install this, we also have a IP address where you can browse it. Where you can browse it directly from your internet browser. So so now, if I go and look at my Yep. Now you can see that my playground is running. Just click on open in browser. It will just take to the browser and shows the interface where we can test our DataWeave scripts. I have also seen in the article, like, instead of just, if you find it hard to locate the Docker location, the image where it's getting loaded, you can also access it in browser locally by just hitting your local host and also this particular port number which we configured. So going back to this Docker, so you can see that it's kind of similar to the one which we have seen in the studio, like it has the input part, DataWeave, and also output. And you can also see that we can change it the way we want here. Let's say if you want to transform it to XML, it's going to throw an error because the XML structure needs a root element. So we need to include a root element. So you can see that it has done the transformation for us. Like you can see the a payload being converted from JSON to XML, and you can try different things here. Like it's very similar to the one which we do in the studio. So you can do various transformations and test your DataWeave scripts, and you can even do your complex transformations here. I don't have the samples files. Something happened with the files which I have. They're corrupted, but I wish I had those and was able to show some of the complex transformations. So that's pretty simple. And let me know if you have any questions, like how to install the Docker or like how to import this image and then make it up and running. As I said, you can, if you find it hard to install it, like if you have any older version of Windows, it won't allow you to install the latest Docker. And then we have an alternative where you can access it directly from the browser, hitting this address here. So, yeah, so this is the other way, which is hosted in cloud, I guess, and you can even access it through your browser. So that's pretty much from my side. Let me know if you have any questions. I'll try to answer, and if I miss something, I should be able to answer at the end of the presentation too.
Yeah, so anybody have any questions, ping me on the message so that I can enable your voice so that you can ask your questions.
Hey, Avinash, I have a quick question. Nishant here.
Hey, Nishant.
Hi, Nishant. Yep.
So I was interviewing actively in the month of July. So one of the questions was frequently asked, like how to convert a payload from JSON to XML.
Okay.
And this kind of answer, like converting the output in the header directive of the DataWeave, can convert the payload from JSON to XML. This was not a satisfying answer, and I could not find another way to do it. So, do you know, is there any other way to answer that question, or is?
I mean, it depends, Nishant. Like, if the interview is being asked from MuleSoft perspective, if you're applying for a MuleSoft position and someone asks you, like, how can you transform the data in MuleSoft from JSON to XML? I think the answer would be the DataWeave component. And then they ask you, like, how you do it. I feel, that's the only way to answer that question. I mean, other people can step in. Arvind, Subhash, do you think, is there any other way to answer that? I mean, I feel that was the only answer from MuleSoft perspective, but I don't know from what scenario that question was asked.
Yeah, I mean, it happened in a couple of calls, so I could not figure out any other way to convert it. So I thought maybe I was answering it in a wrong way, or is there any other way to transform from XML to JSON or JSON to XML?
I think that's the only way. from my experience, that's the only way I guess Nishant. But
okay, yeah.
You have the access now, Manik? Hello? Manik, can you hear us? Yeah.
Subhash, I think Manik is not enabled as a presenter. I guess he's under participants, and that's the reason he's not able to speak, I guess. Yep, he got it now. So.
Yeah. Sorry, I'm back. Yeah. I mean, I'll just add to what you were saying. I would have.
You got muted, Manik.
Oh, sorry.
Yeah.
we lost him again, I think. Okay, let's let him answer once he joins back. Any other questions on this topic? Hello?
Subhash, I think we can move on to the next topic.
Okay, okay. It looks like Arun has one question. Let me add him. Arun, can you talk now?
Hey, I'm back, by the way. Sorry.
Yeah, we can move on to our next topic, and later we can ask these questions. Sorry, guys, we are doing for the first time, so we are having these problems somehow. Yeah. Manik is back. Hey, Manik.
Yeah, sorry, I was like something weird thing was happening.
Yeah.
We can move on to the next one, and we can come back if you want, because we also have time.
Yes.
Yeah.
Tom, you want to take over?
Yes, that'll be perfect. Great. I'm going to share my screen here, and let's see if this works. I'm going to share screen 2. Okay. Tell me when do you see the screen?
Yes, we can see.
Great. Okay. Queuing in the fast lane. I think this is an important description of Kafka and MuleSoft, because if you want to go slow, there's lots of products, RabbitMQ, MQ, and things like that. We've all probably have scars on our back building the queuing systems. And I've worked with companies that really didn't understand what they needed from a queuing system. So that's something that is also a consideration for companies, is how do I embrace queuing, and when should I use queuing, and when should I use straight through transfer, and have kind of this new model of we just do everything serverless and it just flies through. And there's some advantages to queuing that I think people forget about. And at the end of this, we'll do some demo of the MuleSoft with queuing, and we'll be showing the Kafka, which I have running here. Okay, here's an outline of what we're going to talk about, and I'll go pretty quick, but and you guys got the slides. So if I go too fast, just stop me on something. And if you have a question, I don't know whether I can see the chat window, so just speak it up if you see a question out there that you want me to answer. What is Kafka? Why is MuleSoft and Kafka make sense together? MuleSoft is the best integration of tying two things together. Kafka is the fastest, most robust queuing system out there, and is leading the market and growing ever since, growing quite large. There's still a lot of MQ, there's still a lot of other products out there, but Kafka is definitely becoming something of a challenge. Why is Kafka winning? Kafka is fast. Kafka is a fast way of moving data across an enterprise and storing that data into streams, push that out. The way it does it is with zero copy. So it uses the kernel directly to move data faster. So it's less overhead on the systems. I'm running Kafka on my laptop, and I can push enormous amounts of data through it. You can also batch chunk data into chunks. So you can move chunks of data from a producer to a consumer in Kafka, providing more efficiency. Now this is real key, sequential disk writes. So as Kafka is writing and producing data, it's writing it to sequentially, so it's getting high I/O to the disk storage, and that's very important. If you think of Kafka, it's almost like a RAID hard drive writing to multiple drives or multiple parts of a drive to gain that incredible speed, avoiding random access and immediately using a commit log And with no random I/O, disk sequential can be very, very quickly. It's also very horizontal scalable. You can build hundreds of partitions on a single topic and spread those topics out over several servers handling a massive load. Some of the largest implementations, like LinkedIn and B of A and people like that, these can number in the hundreds of servers in those environments. Why do we put it in an application network? Why do we want to put this in our application network? Mostly it's being driven by process streaming. We want to have large data flows coming in from systems where we're getting data off of the endpoints as fast as possible. Web activity tracking, collecting metrics and monitoring for systems. I've seen this at coffee plants where they're collecting data as fast as it can go and they're holding and making decisions on that. Log aggregation. We're all familiar with Splunk, but you can actually put Kafka in front of Splunk and have it aggregate the logs and then have multiple log endpoints at then. Real-time analytics, capturing data from Hadoop or Spark. Spark is another Apache product, specifically on the streaming. Error recovery and rollback is also another option. Guaranteeing distribution of log memories and pushing it out. Who uses Kafka? This list is enormous, and I was working with some customers and they were struggling between MQ, MuleSoft messaging, and RabbitMQ and IB and different queuing platforms. And they ultimately settled on Kafka because they felt that that was the long-term push for them, that they would be able to play with the big boys, be able to move the data in some of this. Now you see big players in here, and you also see some small customers as well using this. Things like Netflix, PayPal, Square, LinkedIn, big banks, Keurig Coffee. Those kind of people are really embracing the Kafka thing. So it's here to stay. Now, if I can do this right, I'm going to do a demo. Can you see my screen right now? And with that, I have my Kafka Apache. Here's my message flows. And I have my Docker. Here's my Docker dashboard. So with Docker, I was able to create a very simple Kafka environment with the Kafka server and a Zookeeper, which we're going to talk about later. And with that, you can see the stats and how much memory, and it's fairly light application. And here's Kafka's running. I'm only running one Kafka server. And I can see the stats and how it's working well, taking up very little CPU. And I'll keep this here as we run this. And with Kafka, I'm using a command line interface. Let me just.
Tom, sorry to disturb. Can you make it as a full screen?
The command line?
Everything.
What does it look like to? Okay, the Mule's full screen.
Yeah.
Okay, so here's the Mule full. I'll put data in a Kafka, and so I have this little application scheduler. I'm going every 10 seconds, and I have a publisher. My publisher is writing out random data. And so I'm writing out random temperature data in a 1000% item here. And I'm using a key offset. So every time I'm writing, I'm putting a key of what the now is. So with Kafka, I'm streaming data as fast as I can produce it. Now on the listener or the consumer, I'm reading that same data and I'm reading that same queue. In the global elements, here I have the consumer. I'll show you that. I'm just listening to the specific host. This is my Bootstrap server. And I'm looking at the topic. I've filtered my topic by the test. So I'm only looking at the test connection. And so very much Kafka is something you guys can get involved with because it's easy. I'm running it all off the laptop. It doesn't require AWS and all those things. The producer works about the same way. Setting it up here, Bootstrap. Now, security, I'm setting up my endpoint to HTTPS. And on the connection, you'll see the plain text connection. There's 4 different types of connections. If I change this to here, then I can use trust store and key store. We're going to talk about that later, but use SASL connection. Okay, so now because everybody loves demos, let's go ahead and run this. This is 7.6. And you'll see that the producer produces these records and the consumer then will collect them. But it connects them from the queue. Even though they're in the same flow, it's actually pulling it from the queue, not from, I'm sorry, from the topic on that. Okay. So let me go back to the slides while this is going, and I'll come back to this demo. Okay. So, and we can do the command line interfaces. Let's look at the basic features of Kafka. The zookeeper, the broker, the consumer, the producer, and streams. So in this diagram, you'll see a good representation of how this all works. The producer gets a broker ID from the zookeeper. The zookeeper does exactly what it does. It keeps everything together. And then the producer then pushes messages as fast as it can to a specific topic. The brokers then talk to the zookeeper to say where they're at, what they're doing inside of the cluster. Now you can have one broker, you can have 100 brokers in that environment, you can have one server. Works the same way. Kafka really scales on a Kubernetes cluster. Then the consumer pulls from the topic as fast as it does. And it then gives the offset of where it pulled from to the zookeeper. So the zookeeper then keeps track of that for the environment. So in Kafka, the zookeeper functionality is kind of the traffic cop to make sure everything runs fast. This creates light objects and everything else. So the broker, the consumer, and the producer don't have to do everything in the environment because the zookeeper is doing that functionality. Now in Kafka 3, this is how it works. Kafka 4, the zookeeper's role gets less and less. And so ultimately in 2.5, Kafka is getting less and less zookeeper functionality as the system gets more mature. Let's look at the core APIs of Kafka. Those are producer, streaming, consumer, and connection. So with the Kafka, especially as we move up to 2.5 version, we have more APIs that we can control a lot more functionality. We're just going to touch on a few of those in this demonstration, but we can go and do all the functionality you see in Kafka. You can now do API driven. So it really lends itself to have a Mule ecosystem where APIs are dominant that we can control and maintain our queuing environment. This is not the case in RabbitMQ. This is not the case in other queuing systems. The 3 key things to remember about the Kafka architecture is the zookeeper, keeping track of the notifications, the producer sends messages without acknowledgements. This way it's so fast, and it just needs to know what broker it's sending to. And because it can send to any broker, you can scale up with load balancing across quite a number of brokers and send that data as fast as possible. So I can have hundreds of producers sending to thousands of brokers all on the same topic. A consumer is stateless, so it can read not only one topic, but other topics and pull back. Consumers can rewind or skip points so they don't have to read everything to get to the last message. So if you have a consumer that's only looking at the orders that are coming out today, you can focus that consumer just to look at those messages and not worry about the rest of the orders. You may have one that's only looking at coffee filters, and you can make that consumer focus just on that and skip around on that. That's a key functionality so that we can get the speed that we're looking for on those 3 things. Now, brokers is a unique concept, and this is just like a RAID hard drive. I'm writing data to multiple places to gain fault tolerance, to gain performance, and be able to increase my reads and write transfers. So just like a RAID hard drive that I might own in my laptop even, I can write data to multiple places and multiple brokers. So you can spin up as many brokers as you need, and you can design and organize your system with the number of brokers as you see fit. And again, you can build it with one broker, like in my example. Now, as you're architecting your consumers and producers, it's kind of like a mail game. I might have lots of producers producing lots of different data, all going to different topics. Some producers go to the same topic. Some producers may go to a single topic. And these could be orders, these could be inventory warehouse functions, all the different possible producers. Mule applications are good sources of producers plus end users. Then the topics are pulled by the consumers. And you see the little arrows, the ones and the twos? The offset of where those consumers pull data from varies based on every consumer so that they can basically pull at different spots. And I can also have a concept called a consumer group. So if I don't want to define every consumer, but I have a group of consumers that want to act in parallel, I can create a consumer group. And the consumer group then can do the function of one consumer, but I have to set it up as a group. So I might have all my external suppliers be a consumer group because I want them to do a certain thing, but they're different actual end machines. A single consumer can consume multiple topics, and the offset is a durable way so that I can restart and resend messages. One of the big discussions in queuing is reliability. How do I make sure that the system's reliable? With RabbitMQ, you can have guaranteed delivery, but it becomes extremely slow. With Kafka, you don't have a concept of guaranteed delivery, but you have the ability to roll back and read messages again. So if you're processing orders and you skip one or something happens, you can go back and get it. So I can set a retention policy, just like my hard drive. I can set a backup retention policy that says, I want to keep these messages in there for 5 days, 10 days, as much disk space, maybe 30 days. Maybe I want to keep them in there for just 20 minutes because I just want to throw them out as fast as possible. But you can set that retention to the business model and make sure that you're holding those messages to give yourself that fault tolerance. Partitions is another feature. With Kafka, we have clusters, topics that are split into partitions, and these are replicated across brokers. So with the partition, messages are assigned incremental counts with an offset, and they're pushed to each partition and written at the same time. There's no guarantee. So this way you're making sure that the data is put in multiple places. Everybody knows fault tolerance is only needed when the phone rings and it's all falling down. We like to get ahead of that a little bit. So with partitions, just like I might partition my hard drive into several sections so that I'm keeping my data separate, I might have multiple partitions in my organization for a specific topic so that I have fault tolerance across that environment. Now, inside of those partitions, the data is written sequentially, as you can see with the numbers, so it's extremely fast, just like writing a hard drive. And then the offsets move to the new. And then topics can be replicated across partitions. Let's look at an example of how we might replicate a single topic across multiple brokers and multiple partitions to allow us to get the fault tolerance. We'll have broker 1 with topic A and B, and we'll replicate that to another topic A on a different broker with a different partition. And then we'll replicate that one to another broker on another partition, and then subsequently replicate that topic back to the other broker. This way, all 3 brokers are kind of balancing out fault tolerance in the system. So I can scale this not server, but multiple servers, and I can scale this across the globe if I have to. And with this replication across partitions, one bad thing is not going to take my whole environment down. And that's critical in the queuing system because often we use queuing for reliability more so than just holding messages. We want to get the messages out as fast as possible, but we want to have that little stopgap in case something happens. So we have leaders and replicas on that. A little review on the architecture. I want to make sure this gets sunk in with everybody: the broker, the zookeeper, the producer, and the consumer. So Mule can act as a producer and consumer, and then with the zookeeper doing the functionality, it keeps a nice tight system. And with the scaling up of brokers, we have the ability to handle terabytes worth of messages. Let's look at Kafka message flow or record flow. Here I have 3 topics on one partition, and so those combinations of partition and topics can vary. And I have a producer who can push to one topic or pushes to this broker. And then the consumer can then read from that topic. And then as the topic is written, it goes out sequentially in the order so that the consumer is reading the 5, 4, 3, 2, 1 as fast as he receives it. And the producer then can produce independent of the consumer. And we don't have the bottleneck on that. So this commit log is kind of like our log4j or our logging system. We're writing it as fast as possible. We're writing this committing once we have a record down there. So we have essentially every record being written in order. Very different than writing a database where we're randomly running around and putting records in a database. So with Kafka, I can send and receive topics on different partitions. I can read a given partition or topic from a consumer and a consumer group. Here's an example of multiple brokers, multiple topics, multiple partitions, all reading the same data in a cluster. This way, a cluster of servers can have multiple brokers, multiple partitions, multiple topics to give us the functionality that we want. So we can spread our work across a lot of equipment without having to replicate or isolate. This is for this business and this is for the other business. Often people put their security in one area only to find that when they have an outage, the area that they didn't have the fault tolerance in becomes critical to the business. Let's look at the shared service model. We came up at an interesting client implementation. We looked at building a REST service in front of the order services, and then every order. Then at that point, because we now knew that every order was in a fault-tolerant mode of orders, we were able to then build the back-end systems of messaging and receivers. Different groups would look at those orders. One person wanted it for marketing. One person wanted to get the address information. One person wanted to get the inventory so they could decide which truck needed to go there. Then the other people wanted to find out whether the order was paid or not paid so that they could basically do forward accounting. All these different functionalities can be done on those orders as long as we know that they're real and they're there. And by putting a REST API in front of that, we were allowing end user to consumers to get that data and push that into the system. We didn't have to help out the back end. We didn't have to write one-off integrations every time somebody wanted something done. Here's another model to look at of where we put Kafka in MuleSoft. One of the key things with MuleSoft is it's easy to build something very complex. We want to build something simple. And what we want to do is define all our objects on the left side, define all our endpoints on the right, and then build 3 shared services model. One is, what are the queues? And I use topics and queues interchangeably here. What are the queues that we want to basically be our single source of the truth? And then what shared services or functionality do we want to do on those queues? I want to receive it, I want to send it, but I may also have a validation step. Like before when we had the orders, we might want a validation step to confirm that that credit card is valid. That definitely will change how I prioritize and what I do with those orders. Exceptions maybe have orders that are not complete and they need more data to be complete. So the exception process can go and add to those orders. So as the exceptions are being handled, what orders are not fully completed, they can be updated into that message data. And then the applications can be built. In this case, the Mule applications or the end user application can be built off to that. And then the app 1, 2, and 3 don't need to build validation or exception. They don't need to deal with a lot of that other functionality. As we build the shared services, we get the reuse. And the promise of MuleSoft is really the reuse of code and organizing our system. Now, there's event aggregation to be thought about as well. Dynamic branching, joining, and data elaboration. And for you SQL guys, this will seem very simple, but in messaging queue, we have the same ability like we have in SQL. So all these events become records. And as we take these events in a streaming model, we can build a branching process where we take suspicious events or valid events. I did a project where we managed in 30 minutes, 6 million records to come in for orders. And with that, we had to separate valid and suspicious order based on some fraud criteria for those orders so that we did not waste the inventory people's time picking and pulling orders that were only to be canceled within hours. So doing that. The other thing is joins. Often data is not always there, so we could take orders and then validate the customer data so that that joined data is more of an enriched order. Using this process, I'm able to then give the end systems an enriched value. And the branching and the joining can be done by Mule. It can be done by another language. It can be done by other tools linking into that Kafka system. So using these data patterns of joins and branches allows us to build a complete system using queuing. One thing we can also do with queuing is data elaboration. We take an inventory item in, and then by adding shipping data, customer data, and orders, we can enhance that event in Kafka in real time as it's flying across the building so that it becomes something before it hits the retailer of something of value. This way we can instantaneously know what's going on. I worked with a client where when the phone rang, as the person was getting a ring on the other end, we were not checking their credit, we were checking what house they had. We checked to see whether that house was a hotel room, because we knew fraud came from hotels for this client. And we also checked to see whether this person was calling with a fake ID or a name and not a real person. So we knew this person was just phishing maybe for pricing. So that was extremely helpful to do that very fast as the phone was ringing. So when an operator got the call, they knew if this was a legitimate person or not, and they knew not to waste their time. They also knew that if this is a valid person and they liked Rolex watches, that to spend time in that environment. And the critical thing is to do that as fast as people ring the phone. Let's look at Kafka security for a moment, because this becomes a big critical thing. As you saw, banks and a lot of the players on there, security is utmost important, especially when you're having this data at somewhat rest. So encryption is important, and you can have encrypted messages, SSL and authentication, and the Zookeeper authentication. So with that, what we do in Mule is we have a trust store and a key store, and we'll talk about that a little bit later. And each broker has its own key store, but they share the same trust store. And with that environment, then the certificate authority and the CA, the private and the public key, can be shared that way. So the Mule applications can have the same trust store as the broker, and then they can leverage that as they link into the systems as there. So the trust store is the same for the brokers, all the clients being held. Each broker has its own machine. I'm showing you a little screen here where if I change it to SSL producer, I now get the key store and trust store settings where I can put those values into the connector. Look at this slide, and this is something you want to make wallpaper up. This is something to bring up at parties. People love this slide. This gives you a little idea of how the flow happens between the broker, the certificate, the key store, and the trust store. So the importing and the exporting of that. I won't cover this because it takes a little bit of time to cover this type of functionality. Just know how it's all being worked on that way. Here's an example of multiple brokers in a cluster connecting into the Zookeeper and the authentication and security between those. And the Mule, you're seeing HTTP, a lot of that is HTTPS. So we're basically doing HTTPS on that and then doing ACL or limiting those assets to reach those brokers. So if you lock down the access to the brokers, blocking that so they can't do certain things. And then if you have a proxy, only letting certain Mule functionality reach the Zookeeper, which is some of the control. Kafka monitoring. There's a little army of companies building Kafka monitoring solutions, resource utilization, threads and JVM usage, and replication stats. Here's an example of some monitoring technology, and you can see measuring this and measuring the queues going in and the average latency of messages going across. And this is fun eye candy for customers to say, hey, we're doing 10,000 messages an hour, and that's kind of exciting to see that. But what we really want to care about is where the problems are breaking. We want to see issues in the broker. We want to see the connection. We want to look at the Kubernetes cluster and the schema. We want to be able to give that data to incident response compliance. We want to be able that the SOC can see that data, because hacking is going to come, and it's going to come not through the web page. It's going to come through these type of environments. One of the things that's important in monitoring is to decide what matters. So the data platform, we're looking at the assets, the events, and the logs, and the testing, and we want to break out these different groups of governance, security, service desk. What do they need to know, and what metrics need to matter? Not everybody needs to see everything on the Kafka. Each group needs to see different things, and this is often too much information is given to the wrong group, and they can't make a decision. Real simply here, we can look at a Kafka monitoring scheme and see all these metrics that we can pull on the system. But really what we want to do is boil it down to really what matters. Here, the consumer lag. How much lag is the consumer behind the producers? Meaning the producers are producing so many messages, but the consumer's not pulling them off. That lag is really what's important, and that's a huge driving factor. You can see in this example where it was low and then now it's high. You want to see why that happened. Why did the lag grow in that environment? So stamping out the lag makes everything happy, because when the consumers are taking data as fast as the producers are producing it, everything seems to work fine. Let's look at a Kafka deployment. This is my Docker, and I was able to create with a very simple script, YAML script, which I'll give you at the end of the day, all these Kafka servers, and then one Zookeeper. I use BitMe, and there's a couple different Dockers for that. And with that script, you can basically use a build. 9092 is the default port on that. I also recommend people hide that as well. And then you set the Zookeeper up at 2181 in that environment. And then you set up the separate server the same way and just basically add those ports. And then I can set up the SSL listeners, the passwords, using my YAML script and create that environment. And then I have a script that creates my key store and my trust store for the Kafka environment as well. It comes with the BitBoomi. Let's look at Kafka and Mule. Okay, now let's go back to our Mule. We see our Mule running. Go back to the log. And you can see it's producing temperatures as we go along, random numbers. And then with the command line, we can interject and introduce messages as well. So I can go back to the Mule, and very quickly, I can start seeing those messages showing up in the log. See that? Hello, North Carolina, welcome. And with Kafka, we have commit, consumer, listener, publish, and seek, and batch message listener. 90% is consumer and publish on that. Different, very small use cases for seek, like if you wanted to have a seek at the end of the day to do something, and then just pulling these messages off. And it's not any harder than that. I think Kafka does a great example, and I think it's important to understand where to use it. That completes the presentation. I wanted to give you guys some trivia. Can you guys hear me?
Tom, Arvind here. Quick question. Tom, can you hear me?
Yes.
Tom, would you be sharing this presentation?
Yes. I gave a copy of the presentation to Savannah, and I think it was hitting your way. So yes, I have a copy of the presentation, and also I have a jar file of this little application.
Yeah. If you could send that to me and Subhash, that would be great.
Send that to you now that I got your email on there.
Yeah.
The two trivia questions before we get back into the trivia question is that why did they name Kafka Kafka? What was the reason for that? What is it named after? Anybody can answer?
Yeah, anybody can answer. Yeah, fast data. Okay. Somebody message fast data transfer. Yes, it is getting recorded, Anshuman.
I can't see the answer. So say the answer once you see it.
Okay. Well, let me tell you. So Santosh Divela said it's fastest queuing, fast data transfer.
No, why did they name Kafka Kafka?
I think it's named after an author, Franz Kafka.
Correct. And he wrote a lot of books, and Kafka has the ability to continuously write, and that's why he thought of that. Another piece of trivia is and this is just trivia too, Bank of America, what was its original name? Anybody?
Yeah, somebody said bank card.
No,
Dhananjay said Bank
original name when it very first started.
Bank of Italy.
Yes.
Shibi Varghese. Okay. Shibi, you are right.
You were right on that one. I have some other Kafka trivias that are in the slide.
Okay.
And those were given to me.
Yeah, we can ask later. Like, I mean, let us ask anybody has any questions. Like earlier, we cannot answer. Nishant, you want to come again with your question?
So my question was with the DataWeave.
Yes, DataWeave. Why? How to convert that
how to convert the
JSON to XML, right? Yeah.
or a data from JSON to XML.
Correct. So Manik, you want to share your thoughts on this?
Oh, okay. So it depends whether you're talking about Mule 3 or Mule 4, right? Like Mule 3 also had some other JSON to object or the XML transformers, not the DataWeave.
Or version.
It was Mule 4, right? So Mule 4, I would say the same what you all were saying. That is the only way. You get a JSON, you map your whatever mapping you have, you change your output type to any data type that you want, and that would be the way. And if I am answering that question and somebody tells me, nah, that's not the way, I would ask, okay, please help me understand better and tell me the other way so I can answer next time, right? So yeah.
I mean,
anybody
who is asking you a question is not always right. So sometimes, like, you should basically say, I mean, this is what I know. If you know something different.
Exactly.
Yeah. I mean, that's fine. So,
Srinivas, you have a question, so you want to ask it? Srinivas?
Any questions on Kafka?
I think there was one, Rajiv asked, since we have a retention period for messaging, is it possible to manually retrigger the message again to consumer?
Yes, and that's critical to do because if I have systems that are unreliable, that may be mobile devices, or let's say a truck going down the highway and he's supposed to get a message about a delivery, if he doesn't get it or gets it incorrectly, he can go back and get that message. And that ability to go back and get a message is critically important. Good example is if I have a delivery truck, he may be getting 5 deliveries that he's supposed to get. Everything's fine. He then finds out that he's got a flat tire, he's got traffic. He's now being rerouted across a bridge. His now delivery changes and he gets brand new messages sent. And that type of back and forth and getting it again gives you the reliability.
Okay.
So yeah, I have another question for Kafka. So like in JMS or ActiveMQ, we have a dead letter queue mechanism, right?
Yes.
For the failed messages.
Familiar with what you're talking about.
So
there's not a dead letter queue in Kafka.
There is a dead letter, same mechanism is there in Kafka?
No, there's not. And that was one thing that was an issue for one of the clients that I was looking at. They were kind of hugging that dead letter queue concept. And the dead letter queue is because I have messages expire. If I can retain the messages for 2 days or 3 days, basically only limited by disk space, which is like water, I can then hold the messages and I don't have a dead letter. And because my pointers can change, I might have 2 processes in my environment. One is reading every order every minute as it comes in and processes it. One is a catch-up process that maybe goes a day back and finds all the broken orders. But instead of putting them in separate buckets and having all these dead letter queues, you can do it in the same topic. The coffee company started with doing dead letters, and so when they had 25 queues, they had 25 dead letters, and all of a sudden they're up to 75 queues that we're trying to manage. With Kafka, I can manage less queues and more pointers in the queue. Does that answer your question?
Yes, but I'm a little confused, like how it is being handled. Maybe that's a more deep dive topic.
Yeah, the answer is there's no dead letter, and you just retain the messages.
Okay.
But that's a great question. That's a big concern for people to make this leap.
Rajiv, you can talk now.
Hey, Tab.
Yeah.
Hi, Tab. This is Maruti Ariga. So I have a similar question around that. So is it always going to be topic based, or can we use it as a point-to-point, like a queue?
Yes, you can have, like in my environment, I can have one topic, and both the producer and the consumer reading and writing that one topic, and it feels like the word queue to you. So topics and queues with one broker feel the same way as a message queue from IBM or anything else. So when you saw my laptop, you saw one topic, and that's equivalent to one queue. So I don't have to bite off all the complexity all at once.
Oh, okay, got it.
And
Thanks.
I recommend people start with that. You know, you don't need 15 brokers. You don't need to bring up a cluster to start. You'll find that with the speed, you may not even need a cluster. It'll be that fast. It's incredibly faster than anything else you're going to deal with. So if you build one broker, one zookeeper, one Kafka server with one broker, you're fine. And then as you grow, you can just start, without changing any of your Mule code, add more brokers, and it just becomes a load balancing issue. It's like standing up multiple web servers. You can stand up as many as you want as your needs change, but you can build everything with one.
Yeah, right, thanks.
Yeah, can you hear me? I have one question.
Great.
Yes, we can hear you, Rajiv.
So I ask, how can we, re-trigger the messages from Kafka?
How can I retrieve the messages from Kafka?
Re-trigger. Yeah.
You're saying retrieve?
Re-trigger. If you want to reprocess the same messages,
Oh, resend?
Yes.
Okay. In Kafka, I can take a message that gets written to a topic and I can replicate it to another place. And if I want to, because the messages stay in there like a linear tape, just like as you walked in the sand and you left foot tracks, they stay there in the sand. And if you want to go back to a specific footprint, you can just change your pointer and go grab it. So if I want to get all the messages from Friday last week, I just change my pointer. The messages are all there in the same topic. So it's not like Rabbit or MQ where the messages fall off the edge at the end of the day or after they've been read. So you can read them over and over again as many times.
So do we have any UI for that, or how?
There's a bunch of UI tools for Kafka, and there's a bunch of monitoring tools for Kafka. And I didn't want to dwell on some of those tools, but there's lots of free monitoring and free UI consoles for that. So you can create brokers, create topics, and I have a command line here. I can do a command line to create a topic. It's very simple, but there is a UI for that as well.
Okay, thanks.
And the two things I want to say about Kafka, since we're all professionals here, is it's kind of like I don't want to badmouth any language or anything, so I'm just going to not say that. But the wind is blowing to Kafka, and you're going to see customers and people who don't even know what it does say they want it. So it's one of those things where you got to kind of get on board. The other thing you're going to find out is that when people get queuing going, they quickly start to blow out as far as the number of messages and the number of things. So when they don't think they need performance day one, ultimately later on, a year from now, they're going to be pushing out an enormous amount of messages. And that's what happens to environments, is that people may start with Rabbit and MQ and IBMQ because they're moving a few messages a day, and they quickly outgrow that, and then they have to tear it apart and make a complex system, and they have to build all these dead letter queues and build in all this redundancy. With Kafka, the same thing on my laptop looks identical to something as big as a football field full of servers. And you will make more money with Kafka than MQ. Everybody clear on that?
Yes. So Tom, I hope the connector is out of box, right? No premium connector for Kafka.
No, it's not a premium connector. All the Kafka is open source. So instead of buying licenses or any of that type of stuff, it's all ready to go. Some of the monitoring tools are open source, so you can find those. I can do things from command line or from simple GUI. So to me, it's like the MySQL of queuing, because big companies can run with it, and big databases, big queuing systems can run with Kafka. And because of people like LinkedIn that actually built it themselves but gave it back to the open source community, I think it's huge.
Okay,
I personally think MuleSoft should buy it, but that's just another story.
Great.
And I don't know if you can see my screen now, but no, the extremely simple. And then I've not had an issue where small development teams couldn't pick up Kafka as far as a learning curve, or it wasn't complex for them.
Okay, I have another question.
Sure.
So there is a publish consume operation in JMS or the ActiveMQ. Is it similar available in Kafka?
There's the same equivalent of what you see in MQ in Kafka of publish and subscribe and that.
So that Cronus operation, like it waits for the replies.
Well,
it's a superset.
In MQ, I publish and then I wait for a reply to make sure the message is on a queue. Yeah. In Kafka, the publisher publishes and does not wait for the topic to tell him he got it.
Okay.
So you fire and forget in Kafka, and then the messages stay on there longer so the consumer can poll and repoll and change its pointers to pull more messages back. But the leap of faith you have to have with Kafka is that the producer puts something on a topic. So some people are concerned with that. They want to know that they absolutely got the message there. And putting a reader after a consumer is a way to find that out. But to hold back the writing of messages, to read, to validate each one, becomes a showstopper for a lot of large enterprises. The fire and forget is definitely something I think we're going forward, because the reliability of the systems are there. And once I replicate across multiple brokers, I usually don't have a problem with that read capability. Okay. So you can tell that the message got sent, but let's say you sent a bad message of a producer. I would want a validator to validate that messages are getting on my topics correctly. So my orders have maybe 3 critical things: location, part number, and customer ID. I might have a validator that validates that all my orders on that topic are correct, and let that validator be the traffic cop to say, whoa, I got some bad data here, and let that stop you versus stopping the producer.
Okay.
On that. So that's a couple of little challenges with Kafka. It is different. And I come from old time, I'm not as old as I look, but I come from old time messaging systems, queuing systems, and all that over committing and holding and backing up slows the process down, and you have to build layer upon layer, only to find out the producer wasn't working anyway. And when you thought something was working, it's not. I want the producer to get the messages off its plate as fast as possible so that the fault-tolerant Kafka system becomes the single source of truth. I know that that will stay up much longer than my endpoint, because I could have a producer that's a cell phone and a person is producing a record saying they're placing an order. I don't know. I don't trust that cell phone. I trust Kafka. And the consumer may be sketchy. It may be a truck driving down the highway. He may consume messages. He may stop and start. He may have to reprocess messages because of bad behavior, or have end customers, maybe other trucking companies that are not my own, that are basically reading these messages. And I need to make a system so that they can read them without, if they're not reliable, they can clean up their own mess. I can't force them to be reliable. And I don't want to rely on anybody. I don't want to rely on anybody outside my 4 walls. Or in this case, my basement. No, it's a big companies are putting huge resources into this. The monitoring and the tool sets are large. So I don't think you're going to have any problem getting your hands around it as you run it. But like I did, started small with Docker, and I just set up a little Docker, and I can even run Kafka on my Windows laptop and run that and be able to push messages in and out. But then that gives me the guaranteed delivery. The thing that concerns a lot of people is that if they build all this dead letter processing and all this guaranteed holding and back and forth, they never get the product out the door. With Kafka, I was able to make those flows within minutes. So you can be up and running within days.
Yeah, that was great.
No, I'm glad you like it. The next thing I'm going to do a presentation on, and I want to get feedback on this, and you can just send me an email, is people are looking at doing streaming, but that's a much different concept. That's when you're taking continuous thousands of messages a minute and processing it in a stream processing, almost like your Netflix. And that stream processing, Kafka and Spark, which is another Apache product, combined do a good job. And we've seen that processing.
Yeah.
We
can definitely have a next session. Definitely.
Tom, Arvind here. I think like Spark is more of a streaming software, right. And then I mean, big data. I mean, when we talk about Hadoop, it's all stable. It's like static. But then when we talk about Spark, it's basically in motion, and then it's kind of a streaming data. So yeah, I think like we can target for that next time.
Yeah, I hear these people talk about flow through processing where stuff just happens and there's no stopping.
Mm-hmm.
And that gets business people excited because data at rest is a problem for security.
Mm-hmm.
Data at rest becomes a point of failure. If things are just streaming fast and they can take all the orders that they want in an hour and there's no friction, I think that's where things are going to go. And if Mule provides that functionality with Spark and Kafka, I think that's a good combination.
Yep.
Yeah, that's great.
But streaming,
so great information, Tom. Yeah.
Spark.
Apache Spark, Kafka from Apache free, and then Mule not free.
No. I understand that, but then all I'm asking is like is there a connector for Spark like we have a connector for Kafka?
I think you use the Spark on the other side of the Kafka. So I might push data into Kafka, Spark, and stream it in there.
Yeah.
Then it gets into Kafka, and my Mule pulls it out of it.
Oh, got it. Understood.
So yeah. I think it's on the other side. Now, I have worked on a project where we did use Spark and build some things to use Spark with Mule, but that was more custom API stuff.
Okay.
But this streaming world is going to be definitely. You think of like a car driving down the highway that's a Tesla and all the data that's got to go back in and out of it just so it stays on the road. That's an enormous amount of data. And if I have a truck with orange juice on it, I may decide to deliver that truck to different grocery stores based on need, based on price, based on whether who's got COVID or not. So all that dynamic pushing of data back and forth as things happen is definitely moving in the right direction of where people want to go.
Absolutely. I think like this is a fantastic topic to stay on.
Yeah.
No, the other thing is we need to almost educate the non-technical people about what we're talking about, because I've sat in meetings with business people and they absolutely thought the opposite of what was happening, and everybody in the technical side just kind of winked and said, we're just going to do what we want anyway. But I think it'd be important to let those people know somewhat what's happening, because they get panicked about reliability and they get scared about what's the replication. If you can show them a system that for no extra money can replicate, all they got to do is buy things with power cords. then you're ready to go. Now you can get managed Kafka services from other cloud providers. I don't think you need it. But there is other products, and there's lots of monitoring tools you can get involved with. I'm looking at using Kafka to replace my logging, so that everything going out of my system is going out of Kafka queue. So if my orders are going out of Kafka, my logs go out of Kafka, and then somebody says on the other side, I'm going to use Splunk. Great. And then the other guy goes, hey, I'm going to use something that's like Splunk, but it's different. It's Logarithm. I'm going to use that. That's fine. And I don't have to make a separate connection to each one of those. All I do is push my data out to a Kafka topic and then force them to decide what they want to do. Because if you give them the choice, different groups will want different things. The marketing people will have their tool. Somebody will have Tableau, and they'll do something with that. And then Logarithm is great for security analysis, and Splunk is great for just archiving logs. But maybe somebody's using Elk, and they want to migrate to Splunk. I don't want to have to rewrite my Mule when they make the change from Elk to Splunk to Logarithm, right? Because that's what we do now. New CIO, all of a sudden he changes the 5 top product, and we make 5 new Mule connections. We want to basically write to a standard and then say, okay, you get the data out of that.
Yep.
No. Even I think.
I would love to come up and see you in Charlotte. I'm not that far. I can drive.
Sure. Definitely, we can have an in-person meetup once the COVID.
Get together once all this subsides actually, and then we can hang out.
I think, Arvind, we are running out of time. Let's start trivia quickly.
Okay, sure.
Arvind, you are on mute in case you're still speaking.
Arvind, you are on mute.
And first,
Hello? We lost Arvind. Where is Arvind? I think he logged off. Okay, I can start trivia questions. Okay, let me try to host mode off.
Where did Ross Mason, the founder of MuleSoft, where did he start the company from?
Malta.
He was just waiting for that question.
Can you hear me? Can you hear me?
Yes, we can hear you.
Okay,
you can
start
presenting.
my screen now.
Yeah.
Looks like the first question is already
before
answered.
that every question you can answer in the chat, general chat to all the participants. Yeah, they can start answering in the general chat. Yes.
And I will.
So whoever answers first, we'll add it to that wheel.
Okay.
And Arvind, I would say just put it in presentation mode because we can see other questions too.
Yeah.
Okay. When you flatten a payload, it returns an object in DataWeave 2.0. True or false?
I think Hari said true. Santosh said true. I think everybody said true except Vijaya and Nadeem. So it's false, right? It returns
it is
array.
false.
Yeah. So Vijaya, let me add it to.
No, I think
that.
Subhash, if it is B, if you scroll up, I think Nadeem answered the right answer first.
Oh, yes. Okay. Then I'll give it to Nadeem.
Yeah.
Okay.
All hands on keyboard.
Next question.
Okay. Next question.
Guys, I don't need to read out. Just take a look at it and then answer it on the chat.
Can we use a separation line between questions because the options will mix up?
Yeah.
Yes, we'll do from now.
Let me know when I can move on to the next question.
Yeah, okay. Let me see who answered first.
Now we can, I think Yuresh is the first one. No, actually,
Okay.
Hari Manan.
Hari? Okay.
Yeah, that's where you can see it starts with, I guess.
Okay, let me add. Let me add before next question. Let me add the lines.
Yeah.
Okay. I don't know. Yes. Can you see my lines, or somebody can?
Let me do it. So
yeah, some problem with me. Yes. Now.
Next.
Yeah. Okay. I think once again. Do it once again, Manik.
Already done, right? Answer.
No, it's still second trivia question 2 only, right?
Yes.
Yeah, but
okay. Now let's go to the third question.
Did you get who answered the second one?
Yes, Hari.
Okay.
Okay. The third one.
Arvind, for next one, I will suggest wait for switching this slide for Subhash to say go, so that we can make sure the separation is already out there.
Okay.
Right.
Okay, it's C. I think Santosh answered correctly.
Avjit, they. Subhash, it's Abhijit, I guess, right?
Okay.
C.
Okay. Okay, I got Abhijit added.
Okay, wait. So separation line first. So we can. Okay, so Amresh put in separation line there. So anything after this will be for the next answer.
For this question, after Amresh added separation line, I answered first.
Oh, okay. Hold on. So all phone lines are closed now. Don't answer for trivia 3. So next question now.
Move on to the next question.
Yeah.
Okay.
Trivia 4 answer now. Okay. 4C. Okay. Probably. Tom, what would be the right answer then? No, the wrong answer.
That question, they're all correct.
C is the right option. It has select the wrong answer.
So what is the wrong answer?
C is wrong. It doesn't support random disk. It supports sequential.
Okay.
C is wrong. It does. That's sequential is faster. Random is bad.
Then it's Ashok, right?
Yeah.
Next question.
No, hold on. Let's put the.
Yeah, for the fourth one, I answered like A and B. I mean, initially said like it's a sequential. So I said like A, B, and C, then I dropped up the C option.
Select the wrong answer, which is C. So the answer to the question is.
So Ashok got the first one. Separator line is out there. So we can
go to the next one.
Yeah. 5B.
Do you want the answer?
Yeah, we have so many answered already.
The answer is B.
Rajiv.
Anybody is the clear winner?
Yeah, Now Rajiv is there. Subhash, just make sure if you don't get twice. If anybody has already answered for another question first time, we'll pick the next one. So Rajiv is here now.
Should I move on or
wait? I'll put that one. Okay, separator is out, so you can move.
Yeah. Some reason I was having problem. I'm back. Sorry.
That's okay.
Can I get two other names?
So for the previous one, Rajiv answered first correctly, and we are just taking the first answer, right?
Right.
So it's
Nadeem,
Rajiv
Hari.
first.
Third one, who was third one? Avijit?
Yes.
Then fourth question is what you said? Rajiv? Fourth answer is Rajiv?
Ashok. Fourth Ashok, fifth Rajiv, and sixth is now we will see.
Okay. Okay.
Do you have enough members to basically pull your draw?
No, two more.
Okay.
So this one is
the answer C.
C. It's again Ashok, so I would say skip over him because he's already in the list.
Okay, who is next then?
No one answered it correctly. Yes.
Now Santosh answered it. We broke it. Okay.
That's a bad question because I'm thinking all those people are starting to use Kafka.
So,
the questions are confusing. The second one it says which is not.
Anyway, we have an extra question.
Certification exam, they confuse you.
Yeah.
And then you should not get confused. It is like that. Their job is to confuse you, and you should not get confused.
Yeah.
Subhash, we have an extra question, right?
Yes, 8th question. But what is the number? Is it a 6th question or 7th?
Yeah,
I can't see.
This is 6.
Oh, we have 8 questions. 7 is actual 7, but if there is some draw or something, we can go for 8th question. Yeah.
Okay.
Who was the winner for 6th?
Nobody answered until we announced the answer.
Okay.
And after we announced, Santosh answered it. So I don't know if you want to still consider him as a lucky person.
I mean, I think we'll give 0 for this one.
Okay.
Let's move on.
Okay. Next.
Separator is out. You can go. Oh, function.
We should make this a drinking game.
Yeah.
I think Nadeem already answered one correct. So
yeah,
when is the next person?
Okay. Last one to go.
Yeah, we this is the last one, right, Subhash?
No, there are 8 questions, right?
Yeah. Okay. Let me go to the next one.
Oh, hold on a second. We need to have separator. Yeah, there we go.
Yeah. Next, you can go. That was so quick.
Santosh got it this time.
Okay.
Santosh. Okay. So let me share my screen and run that wheel so that we can find out who is the 3 luckiest winners today. Okay. Let me share my screen quickly.
Mm-hmm.
Is it Wheel of Fortune, Subhash?
Yes.
It's wheel of what do you call it?
Okay. Can you see my screen?
Yeah.
Yeah. So 7 members: Nadeem, Hari, Avijit, Ashok, and I don't know the full name of Ven Santosh. Okay. Let me start now.
Yeah. These ones should be fine.
Ashok. Oh, Rajiv. Right.
Yeah.
Rajiv, you are the first winner. Santosh, you are the second winner. Okay, the last winner today. Oh, Ashok again. Oh, Ashok. Okay. Okay, I think we got the 3 winners. So, Ashok, Rajiv, and Santosh, please send me your email address. Ping me here so that I can send you the details to get the free training and voucher. Okay. You can conclude, Arvind.
Yeah, thanks all for joining. I mean, this is a great session. This was our first virtual session. We are planning to do, this event every 2 to 3 months. And please, we will send out a survey with more topics and things like that. You can suggest topics. And then I also need presenters for the coming meetups. Please feel free to send in your names and then your topic of selection. I think we can make this a great platform to learn from each other. Thanks all again for joining us for our first virtual meetup and seventh Charlotte meetup. Have a good evening and see you all again.
Thank you.
Thank you. Thank you. Good night.
For having me.
Thanks, guys. Thanks.
Yeah, thank you all.
Thank you all. Santosh.